All right, folks, let's get started. So hello, chemists. My name is Dr. Lisa Wynn, and I will be your instructor for this term. So I know that we're all eager and excited to get started. So we need to go over some course logistics first. Well, actually, before I start this PowerPoint, let me show you how to get to this PowerPoint, all right? So hopefully by now you have visited our Carmen page, right? Our Carmen page looks like this. So, so there's a lot of people involved in making the success of this course run. There's a lot of people, all right? So a lot of what you see on this homepage, I actually didn't make. The things that I make and the things that I share with you, you will find under the modules. That's where you'll find everything. Hey, folks in the back, there's a second floor, all right? If you just kind of turn around, there's a staircase and there's a second floor. So yeah, everything that I post and I make, I just put under the lecture modules and recitation modules. I am not responsible for anything else in this course. So I'm glad that you all made it to recitation, or sorry, we're not in recitation, we're in lecture. We made it all to lecture. So how to find resources. So the slides that I am working through today are underneath lecture material. So we will go over the intro and syllabus slides that I have up right now. And then we will also start chapter 1. So I post all of my lecture slides under this module organized by chapter. And you'll see also here within lecture material, just because I don't know where to put it, I have other resources for you. So such as, what is that? I don't know. Meet your instructor and course logistics. Is there a question on Zoom? Okay. Course logistics. So here, basically I just summarize all the content. Is there a question on Zoom? If not, can you just mute yourself? If you haven't noticed, I'm zooming in also at the same time because I am a millennial. So on this page, Meet Your Instructor, I summarize a lot of the components of the syllabus in list form, just so it's easier to read. And if you have emailed me already with questions, typically how I respond to emails and how, especially at the beginning of this term, and in those welcome emails that I've kind of sent out to you guys, I always refer you to what? The facts page, all right? So this page has about 99% of the questions you may have. There's two reasons I have this facts page. It's one, for my mental health, because I answer the same 3 questions probably 50 times a day. But the second reason is because when I, navigate you to this facts page on our Carmen page, I can put links to all the details that you need to know. Like if I say, okay, refer to the recitation schedule, I can link to the recitation schedule. So that's why when you send me an email and I just say, hey, go to the facts page, it's because I can link all of the important details that you need to know within Carmen. So if you have a question, feel free to email me, but probably 9 times out of 10, your question is on this facts page with the relevant link. So this first one, I'm under quarantine, or, I can't come to class, what do I do? Here's the list of all the resources that you have available to you. Okay, so that's basically this course. So let's go back to the logistics slide. So I hope that you have this in front of you. So just a little bit about me. I am Dr. Lisa Wynn, so you can call me Dr. Wynn or Dr. N. All right, I grew up in Pennsylvania. I came here to OSU for graduate school, so I studied chemistry here, and that's where I got my PhD. Actually, when I was a student, my office was actually just right behind this wall. All right, so at the end of class, we will end class with a boom today, and when I was a student, on the first day of class and on the last day of class, it was just like booms going off all the time. And so it's really fun to kind of be now teaching in this space when I was just a student, like just over there. So it's kind of, it's all come full circle. And so I have been teaching at OSU for a couple years now, but this is my second term teaching at OSU main campus. I was at a different campus for a couple years, but this is my first time teaching 1110 here, so just be a little bit flexible with me. But good news, chemistry, it's the same. I've taught 1210, and so the content is the same. I just teach it a little bit differently here. But anyway, just be patient with me. A little bit about me. I was named after Lisa Simpson. I already said I'm a millennial, so that kind of just shows my age. I was named after Lisa Simpson. Those are my cats. Those are my chickens. My 3 favorite places on earth are my home, so my farm, Disney World, So that's me at Disney, and Costco. Those are my 3 favorite places in the world. And I like cooking. So I think cooking and chemistry, go together a lot here. So the big thing about chemistry, and what gets me so excited about it, is that the concepts that we learn in chemistry is so easily applied to what we see and observe in our everyday world, and that's what I hope to bring to this class. Okay, so logistics of this class. You are here in lecture, all right? I will be your lecturer. We meet twice a week, Tuesday, Thursday. You signed up for a lab, all right? So that meets for 3 hours every week. So thankfully, and we'll look at the schedule here soon, lab will not meet this week, so that's good. And I'll go into more details about that. Also, when you registered for your lab, there was also a recitation that kind of was combined in that section. So when you registered for lab, there were 2 classes listed. One was 3 hours long, one was 55 minutes long. The 55-minute long class, that is your recitation. So you may not have ever had a recitation before. Essentially what it is, it's a small group learning environment where I provide an activity, and you essentially work through that activity with your teaching assistant in a smaller group environment. It'll have a much different feeling than like what we feel right now in this lecture room. I will not be your I won't be there in recitation, so don't expect me to be there. It'll be a different teaching assistant to take care of you. Some of you already had recitation. How many of you? Oh, wait, a lot of you, okay. Did it go okay? I was worried. It's always weird when you meet your teaching assistant before you meet your lecturer, me, and it's always a little bit weird, all right? So hopefully that went okay. So all of those things have in-person components, lecture, lab, and recitation. I'll talk about the point breakdown in a little bit, and then we also have online homework through Mastering Chemistry, and a lot of that information that we talk about on our Carmen page, right? Okay. So let's just keep going. So what to expect? We have 2 lectures a week, 1 recitation a week. How online homework is organized, what I do is I have 1 homework set per chapter. 1 homework set per chapter. I like to, and we have 12 chapters for this course. We have a lot of material to cover. So 1 chapter, 1 homework set. One of those homework sets, I try to aim for about 90 minutes to 120 minutes worth of questions. So how that ends up being, it's about 1 homework set due a week. Because we have 12 chapters, there's about 15 weeks in the semester, so that's kind of how it ends up going. So the rules, and I'll talk about this later, with homework, is that whenever we finish a chapter in class, the homework for that chapter is due the following Sunday. So let's pretend we finish chapter 1 tomorrow, or on Thursday. We're not going to, but let's just pretend we finish chapter 1 on Thursday. So let's look at a calendar, okay? So Thursday is the 13th, right? So if we finish chapter 1 on Thursday the 13th, when is the chapter 1 homework due? Sunday the 16th, very good. All right, and so that's the 16th at midnight, Sunday at midnight. There's a second floor of seats. If you find the stairs, there's a second floor. So if we finish the chapter, let's say on the 18th of January, when is the homework for that chapter due? The 23rd, Sunday the 23rd at midnight, all right? So that's how it will work. And it'll be very clear when we finish a chapter, all right? So that is how that works. Once you sign up for Mastering, and I'll show you some instructions in a little bit, the grade book on Carmen will populate, like the assignment will show up on your like Carmen to-do list once you sign up. And I think half of you have already done it, so great job. All right, and then you have lab and with another teaching assistant. And I will point out that I am not involved in lab, all right? So if you have very specific lab questions, like if you're going to be missing class and you happen to miss a lab and you come to me, I can't do anything about it. You have to go to the lab supervisor. So I don't have any hands on lab. I can definitely help with concepts, but I am very hands-off with lab. Okay, so grading, where your grade comes from this class. So we have online homework, that's 7.5% of your grade. Recitation is also some of your grade, so it's 10% of your grade. And so how you get recitation points is just by showing up. All right, so In graded recitations, I make an attendance quiz. It's just a way to mark your attendance, so our teaching assistants don't actually have to do like roll call. And so you get those points for recitation just by showing up. After you do the attendance quiz, it only takes like a minute. Then the rest of the time is you use for the activity that I provide. You don't actually have to finish or hand in the activity. It's just for your own benefit. All right, so your grade comes from attendance. And so the absence policy for recitation, everybody gets 3 drops. All right, so only 10, so I guess only 10 of the 13 recitations actually go to the grade book. Everyone gets 3 absences for any reason. Or you can just go to all the recitations, that's fine too, because there's very useful activities done during all of those recitations. And I think, do I have the schedule? Yeah. So here's the schedule. So I know some of you already went to recitation. This first week is ungraded. So once we start next week, week 2, then all of the attendances for recitation will actually start to take attendance. So this first week we won't. It will be ungraded because people are adding and dropping. All right, so that's how that will work. And just know that you show up, you take the attendance quiz, and I provide an activity, and that's all there. And keep in mind that the activities I post on Carmen. So if you are planning to be absent for a recitation, if you plan to use one of your excused absences, you can still do the activity. All right, that the activity is there. And typically I post the key at the end of the week or whenever all the sections complete the activity in class, I will post a detailed key. Sound good? Oh, and keep in mind, so if you plan on missing a recitation, we do not expect our teaching assistants to Zoom those sessions. The only sessions I do Zoom are these lectures, and that's it. That's too much responsibility for them. Okay, all right, so that's recitation. Where did I leave off? So there's that. And then laboratory is 20% of your grade. In order to be a well-rounded chemist, you need to have technique and you need to be in lab. So we have this very strict policy. In order to pass this course, you must get a 50% in lab or more. You have to earn 50% of the points in lab in order to pass this course. You could get 100% on every single midterm, but then not show up for lab and you would not pass this course. And I will say that I had a handful of students who kind of fell in that boat. They did well on the midterms, on all the assignments, but they just didn't show up to lab or they didn't hand things in and they have to retake the course. So you have to get a 50% in lab or more. And I'm telling you, it's kind of hard to do to get below 50%. You would just have to not show up or just not turn things in, all right, to do that. So keep that in mind. Then this is to get you guys to achieve, the learning objectives for this course. In order to be a well-rounded chemist, we have to do lab. Okay, so calculator policy. We've kind of expanded our calculator policy for as a department. So this policy is just for examinations. All right, so we do have midterm final exams that are proctored, they're in person, and we only allow certain types of calculators to maintain academic integrity. So these pictures are the only ones that are allowed. So they're only Texas Instrument calculators, so if you want to pull your calculator out just to see what you have. So like the TI-30 series, the TI-83 series, there can be a plus at the end. It could be 83 or 83 plus. There just needs to be the number 83 in there, or the 84 plus. Also the 84 plus CE is also okay because the number 84 is in there. I know that there's a new calculator going around called the TI Nspire. That is not allowed. All right, so I will point out this is just for midterm exams, all right? And the final exam is when we expect only these calculators. So, I'm not gonna be on your shoulder when you're doing homework. You can use whatever you want, but I do recommend that you use the calculator you plan to use for the midterms, just because you wanna get to know how to use the functions on your specific calculator when you're in an examination. Any questions about that? No? Okay. Okay, so those are our calculators. So here's our lecture schedule. So what you see here, 12 chapters, we have a lot of stuff to cover. Also, our midterms are in class. So this schedule is just kind of a rough outline of the pace that we're going to go through. So I am going to try my best to maintain this pace. The great thing about this, me teaching this class, is you guys are the only 1110 class in the whole university. So you know what that means? that we can go at any pace that we want. We don't have to, maintain, a pace with another class or another course. We are the only ones taking 1110. I will be writing your exam. So if we don't cover something, then I just won't put it on the exam. How does that sound? All right, so that's a little bit exciting from my point of view. You guys probably don't care. But this is just the schedule, the pace that we're going to go at. We have a lot of stuff to cover. Okay, we already talked about recitations. So remember, this week's recitation, it's ungraded, but there's still an activity. So if you can, go to recitation, all right? Did we enjoy recitation Monday, people? Was it cool? Okay, all right, awesome. So a little bit about lab. So I told you that I am not involved in lab, but I do enough or understand enough to give you that information. So here's our lab schedule. So from what you see, yay, we don't meet for lab this week. That's great. But you do have a couple of tasks that you need to complete before your first lab. All right, so remember the lab is the 3-hour section that you signed up for, that lab section. So your first lab is DPR. I don't know what that means. All right, so it's probably somewhere within your lab manual what that experiment means. So before this first lab, if you're a Tuesday lab group, there are some tasks for you to complete. Where is that? I'll just kind of skip down here, tasks for lab. To get access to the Hayden McNeil website, okay, this is different than online homework. And also the big thing is purchase a lab coat from Celeste 180. All right, Celeste 180 is the building next door. It's on the first floor. You need a credit card or your Buck ID. They are open Monday through Friday during business hours. I would suggest not going the 15 minutes before lab because there's probably 300 students all taking lab at the same time, your same time slot. So there's very much going to be a line the 15 minutes before class. The question, I really should put this on the fact sheet. If you already have a lab coat, if you have a lab coat from high school or from another class, you won't be able to use that. The lab coats that we offer in the Chem store are a very specific composition to protect you from flammable substances and from chemical spills. So the lab coats that we are selling are very specific to your safety. So if you have another lab coat, you won't be able to use it unless you bought it from us previously, then you can use it. But if you purchased it somewhere else, you cannot. And then note, and this isn't really an issue in the middle of winter, but make sure when you show up to lab that you have appropriate personal protective equipment, which just means long pants, closed-toed shoes, and your ankles aren't showing. Basically, the rule of thumb is make sure that there's no skin below the belt showing when you go to lab. And this is very important from a safety standpoint. I don't like, monitoring what people wear. It's really, truly from a safety standpoint. And then, so you need to get a lab coat, but goggles will be provided to you when you arrive at lab. So expect that. All right, so how many slides did I skip? A lot? Okay. So that's recitation lab. So what resources are there for you? I already showed you our Carmen page. I put so many resources up there on that Carmen page. You will be sick of it. I just want you to know, how to find those resources. Note that I also have office hours where we can just talk about chemistry. All right, so for this class, my office hours are directly after class. So typically what will happen is we end at, 2:05? 2:05. So I'll stick around for 5 to 10 minutes to answer any questions that people have. I don't know if there's a class in here afterwards, but they'll probably kick us out. But what will happen is I will walk back to my office, and anyone who wants to come visit me for office hours can just follow me back to my office. And really to encourage you guys to come to my office hours and build a relationship with me. If you come to my office hours sometime during this term, I will reward you with a small gift. Okay, I don't know if I will regret this, but a small gift that may or may not help you in your success in this course. It's not extra credit, but it is a small token of my appreciation of you coming to my office hours. So if you come, I will reward you with a gift. If you need to find me outside of my office hours, if you have a class right after this, no problem, just send me an email if you want to meet separately, or we could set up a Zoom time if you want to go over things. All right, so I have office hours, but I'm only one person. And there are 250, I think, of you. All right, so we also have a fleet of teaching assistants that also have office hours, and I will show you where to get that information. So we have something called the Learning Resource Center. It's in Celeste, all right, Celeste 170, so it's that first floor of the lab building. There is always a handful of TAs, teaching assistants in that room for drop-in tutoring, whatever. There's always like 5 or 6 teaching assistants there, and I will show you how to find that. So if you go to our course, go to the homepage. If you scroll down to academic help, this page, and see here, there's a Gen Chem office hours link, so click on that. Here you will see the schedule of teaching assistants in the Learning Resource Center. Oftentimes we call this the LRC. So the LRC is open drop-in tutoring. So you don't have to make an appointment. You can just show up with your questions. They are open Monday through Friday, 9 a.m. to 5 p.m. Right? And so here are the people that are in that room. So you might note here that they have course numbers after their name. It doesn't matter. Just if you have a chemistry question, all these people are chemists. They will try their best to help you. All right? So you can drop in anytime in person, and someone here will help you out. Right? So that's what, 9 to 5. In person in the Learning Resource Center. If that's not enough for you, let's say, maybe you work during the day and you can't make that, there is also a small number of remote office hours via Zoom. All right, and that's from 6 p.m. to 10 p.m. There are links here where you can visit, teaching assistants in their Zoom rooms for specific chemistry questions. All right, is it Monday? It's just Monday through Thursday, so not on Friday, okay? All right, and if that's not enough, okay, these are the after hour Zoom tutoring. If that's not enough, after hours, there's also some on the weekends, all right? Okay, so there's also a handful of hours on the weekends that you can visit these guys in their Zoom rooms also, okay? Who's gonna think about this? I highly suggest visiting this week, all right, the in-person LRC, because no one goes. It's before the first midterm. That's when everyone starts to go. So maybe just, check it out, see what it's all about this first week. All right? Okay. So those guys are happy to help you. And so I'll note here, these after-hour Zoom remote office hours, you need to find this document to get the links to those Zoom rooms. So if I click on one of these right now, one of these links, it will take me to the Zoom room. Okay? All right. So that's actually new the past 2 semesters, and I think that's a super great resource for students to use. You just need to know where to find it. Oh, and I'll also note, because I think some people were a little confused, you can go to anyone's office hours. You don't have to just go to your lab or recitation TA. You can go to anyone. We're all chemists. Chemistry is all the same. It's all the same. We just teach it a little bit differently within the different classes. All right, so I have office hours. Learning Resource Center has office hours. Also, most of you have already purchased the digital version of your textbook. Okay, so if you opted in to Carmen Books, does that sound familiar? When you registered for this course, okay, if you opted in, I think it was $45, like a $45 course fee. What that grants you is access to the e-text and access to the online homework. You already paid for it. You don't have to pay for it separately. Yay, $45, I think that's doable here, at least in my day and age. Spent so much money on textbooks when I was an undergraduate. So recognize that you have access to the textbook via our online homework portal, and I'll show you what that looks like in a little bit. Also, I post a lot of resources on our Carmen page, keys to practice exams and things like that, and I write out very detailed keys. I don't just circle the answer, I write out all the information you need. Okay, online homework. So like I said, always do the Sunday at midnight after we finish it in class. You probably already purchased it. Instructions to register are on Carmen. Under the start of term tasks, there's a document, all right, of instructions on how to register for online homework. So if you open up that document, there's an access code, and it's like a string of random words. Does anyone know one of the words in the access code? No one remembers any of the words? Yeah. What? Dobby. Okay, all right, so the access code is just a string of random words. One of the words is Dobby, all right? And so you will copy that access code, follow the instructions. You have to click on My Lab and Mastering through our Carmen portal. All right, so what that looks like is right here. So you will click on this link, My Lab and Mastering. You will sign up for a Pearson account, all right? And then through that link, you will input the access code to link your account to our course. So if you find a box that says input course ID, that's wrong. You need to look for a place to put an access code. Does that sound right? I actually have never gone through the process. I don't know, because I'm not a student. I don't know what it looks like, so I'm just guessing what it looks like. Does that sound right? Okay. Half of you have already done it, so good job. All right? And so once you've signed up for online homework, you have access to the textbook and the first homework assignment. I already have chapter 1 published. I think 5 of you have already done the homework already. That's great. So some notes about the homework assignment. I really encourage you all to complete questions as we move through the chapter, all right? We talk about the Sunday due date, so like D-U-E, but that doesn't mean you have to do the homework on Sunday, all right? The due date is not a due, like D-O date. That's a joke. Okay, all right, thank you. All right, so I really encourage you all to start the homework, you know, as we begin and start the chapter. There's no penalty to just look at the questions, all right? If you read through them, you're like, oh wait, yeah, I know the answer to that. Then do those questions, all right? But there is a penalty if you get those questions incorrect, all right? So my advice to you really is to fully understand those concepts, what's being asked before answering the question. Because if you really just kind of brute force your way through the homework, what's going to happen is at the midterm, you're just going to have to relearn all those things all over again. I'm a big proponent of efficiency, using my time efficiently. So I will spend a little bit of extra time on homework, really understand what's going on so I don't have to relearn things later. Does that make sense? Okay, so I'll show you what our homework kind of portal looks like. So here's the grading policy. I already said that you are penalized for incorrect answers. I think you can do it up to 6 times. Some of the questions have hints that you can use penalty-free. So I just installed this term. The due date for homework is Sunday at midnight. But last year I had so many emails about extensions, I decided to make a 2-day grace period. So 2 days after the Sunday due date, essentially the points that you can earn kind of die off. So you can continue to do questions after the due date, but for a penalty. It's about 50% a day. So essentially the 2 days after the due date, you can continue to do questions that you hadn't answered already. So like if you did half the homework assignment, all right, you would have already gotten points for that, but the remaining questions you can still continue to do for a penalty up to 2 days afterwards. Does that make sense? Yeah, so that's why, again, I encourage you to get the points for homework early. There's a second floor of seats upstairs. There's a second floor. If you go back, there's a stairwell. Okay, what a question will look like is something like this. So I do want to draw your attention to these resources on the corner here, all right, and use them. So here, a review link, this will take you to the part of the book going over that question, all right, or those topics. What else? Constants, so those are useful information for dimensional analysis. So click on those links, they're free for you to use, and then the periodic table that we will be needing because we are chemists. All right, so use those resources and know that they're there. All right, so I already said about that's online homework. Lab access is a little bit different. You have to sign up for this separately as well. It's called Hayden McNeil access. I don't really know the process. Has anyone signed up for it already? You have? Was it easy, hard? Okay. Okay, all right, so you did have to pay for it with a credit card? It's $65. You might have already purchased it through the bookstore, maybe. If you bought something at the bookstore for about $65, you might have already purchased it. But if not, use a credit card to purchase it. There's a set of instructions as well. And so your fellow classmate was saying the section number, that's always tricky to find. Again, this is also in the facts as well. If you go to your Buckeye link showing your lecture and lab section that you signed up for, there's 2 different courses. Don't use the lecture section number. Use the lab section number. That's the section number that you want to use, and that is on Carmen. I just copied it in my PowerPoint. Okay, we already talked about the tasks for lab. I already talked about my office hours. Again, just follow me after class. We'll have office hours. Also, you can email me directly. You know, I joke, I am a millennial. What do they say, millennials? We destroy the economy because we eat avocado toast, right? I don't buy diamonds, and I'm always glued to my phone, all right? So if you email me directly, I will answer you even if I'm in bed because I don't have work-life balance, all right? So just email me at any time. I will note, don't use my Buckeye Mail email. That was my email when I was a student. And those are actually two different inboxes. So if you want to make sure that I get the email you're sending, just send it to the regular @OSU email. And also don't use Carmen messaging. I don't like Carmen messaging. It like muddies up my inbox. So if you want to get me to respond the fastest, email me directly. Okay. Oh, and also I should point this out, just quickly, like at the beginning, say what class of mine you're in. Just say that you're in 1110 because I'm teaching 1110 and 1210. So if that question pertains to, you know, the section you're in, just quickly tell me what section or like what class you're in, so I can answer your question faster. So then, yeah. Also, you can reach out to your teaching assistants also for those specific questions that they might have. Okay, so we will start class here in a tiny, tiny bit. So just recognize that everything I post concerning lecture is on our modules. All right, so each chapter is where I will put all of the information. So for example, like this is chapter 5, this is what you'll see, lecture slides. I usually post them two different ways, one slide per page and another way 2 slides per page. Just figure out what works best for you. I will put recordings within those pages as well as I record them. And then I also post supplemental resources such as overview sheets. It's just extra practice problems, and any resources that'll help you study. So one of the big things, you know, with chemistry and college courses in general is we don't do all of our learning in this space, in lecture. A lot of your learning has to be done on your own. And so I like to provide lots of resources for you to do that. And also know that your textbook has practice problems for you to do, but I provide a lot of those as well. Okay, so that's what lecture looks like, recitation logistics. We already talked about it, right? You know what to do, just show up. All right, midterms. So we have 3 midterm exams. So in the syllabus, you can see the dates for these midterms. In general, at least for the midterms, they will be during class on a Thursday. All right, how I like to set it up, we will cover 3 chapters per midterm. So once we get to finish chapter 3, we will have midterm 1. The final will be cumulative. All right, so all of these exams are happening in person. In this space during class. They will be Carmen quizzes that you can take on your iPad or your laptop if you do not have an iPad. We use Lockdown Browser, Respondus. Have you guys used that before? Yes, maybe like half of you. Okay, so you will have to install that, the Lockdown Browser before coming to the midterm. We will give you an opportunity to test it out before you come to the midterm. All right, so since it's on Carmen, most of the questions will be multiple choice or like a numerical answer. Okay. Also, you will be given a supplemental information sheet. So that will include the periodic table and any like constants or equations that I might give you. So I will give that to you well ahead of time so you know what to expect when you come in. So keep that in mind that we do give you the periodic table. You are not like expected to memorize the periodic table. The caveat though, all right, with the periodic table is we give you a periodic table that looks like this. So there's no names of elements on it. We give you the symbol, the atomic number, and the masses that you see there, but we don't give you the names. So keep that in mind. So you'll have to know that like carbon has the symbol C. All right, so those are the types of things that you need to know how to use the periodic table when you're at the midterm and final examination. Any questions about that? Okay, you're probably just. No, oh, they didn't change that. No, it is closed note. That's a good question. I told them to change that. in the day and age of COVID, back when we were at the beginning of all of this, it was open note, but no, these exams are closed note. And understand that I am writing the exams with that knowledge in my mind. A closed note exam does not look anything like an open note exam would look like. So this, just to clarify, these exams that we will do this term will all be closed note. So it said open note in the thing? Okay, that's a lie, it's closed note. Question up there. Yes, the academic misconduct quiz. Yes, so there is a fleet of people responsible for making the contents of this course. So I did not make the academic misconduct quiz. I actually caught this mistake last term and I emailed them. So I'm sorry for that misunderstanding. No, all of the exams are closed note.
I was really confused on that.
Yeah, I'm sorry. So I will clarify that. I will make an announcement. So expect all of our midterms to be closed note. But know that, homework, that's open note, right? You can use any resource that you want with homework or recitation. So really the only proctored setting assessments that you have in this course is the midterm and the final. Everything else basically goes as is. Okay, where are we? Okay, so there we go. Almost done. So lab, again, I am not involved in lab at all. So if you ask me questions about lab, I will probably just send you to the lab supervisor. They have their own email that you can see within the contacts page within our Carmen site. So especially if you have an absence, I again, don't do anything with lab. So if there's an absence, you have to contact the lab supervisor for that. But if it's a chemistry question relating to lab, then yeah, I can help with that. Okay, and lastly, a note about the day and age of COVID and absences, sicknesses. This course does have in-person expectations. Have any of you been to a lecture this large in person? Okay, so you have. Okay, so a small number of you have, but I would say the majority of you have not been to a lecture this large. But you're in for a treat, okay? Because if there's one thing I do well, and that I try to bring passion to this space, bring passion of chemistry to this space. So you're in for a treat this term. So yes, this class does have in-person expectations, but I do recognize that we should prioritize student health. All right, so I do have, safety nets in place. I have a Zoom link available so you can Zoom in if something were to happen, if you weren't feeling well, if you have to quarantine or whatever. You don't have to send me documentation. You can just use the Zoom link, it's there. Right? Also recognize that I post recordings of these, so I'm recording this right now, my screen, and I'm recording my voice as well, but do understand that technology issues happen. I already had one in my first class on Monday, all right, where the connection just cut out like 30 minutes in, and so I lost all of that recording. So don't rely on the recordings. It's really there as a safety net, okay? Zoom recordings kind of go against my teaching philosophy, but I do understand we should prioritize student health in this day and age, but don't rely on them. I have the data to back it up. I taught an asynchronous class where students had to watch the videos, and not a single video ever reached, I would say, 50% of the student body. That even when the videos were required, less than 50% of students actually watch them. So I can see students falling into this pit in that they consistently might skip lecture thinking, oh, I'll just catch the recording. Do you trust yourself to watch the recording? So I really urge all of you, if you can, to come to class in person. Fair enough? But I have those safety nets for anyone to use. All right, so you don't have to tell me, if you're under quarantine, you don't have to tell me. You can if you have concerns, but understand everyone has access to those resources. Everyone has 3 drops in recitation. You don't have to really tell me, but you do, if you have to miss lab, you do have to contact the lab supervisor. Okay, all right, we excited for this semester? All right, so let's get started. Let's go to chapter 1 slide. So I'll just remind you where to find that. We go to, not teacher. Let's go to student. Home or modules, we go to modules. Chapter 1, Chemistry Basics. So what you see here are the lecture slides. So what I usually do is I send them to Notability. Hopefully you already have Notability on your iPad, your school-issued iPad. I think everyone gets it for free. I don't know how, but you get it for free. I actually bought it with my own money because I love Notability. So to send it to Notability, I like to just, click on the slides. You go up into the corner here to share, and I just send it straight to Notability into your appropriate class, but I already have it on my thing. And so what you see here also under our Chapter 1 slides are those supplemental resources that I was talking about, to make sure that you use those resources there. All right, so where's my Notability? Okay, let me check on Zoom people. Zoom people, are we okay? Are we okay? Okay, great. Thank you. All right, so let's start with Chapter 1, Chemistry Basics, Matter and Measurements. All right, so this chapter really sets the tone for the rest of this course. All right, it's a really long chapter. All right, so I don't think we'll finish it in 1 week, but we will try. A lot of the important chemistry, again, basics are within this chapter. So what we're going to talk about this in this chapter, it's kind of split up into 2 parts. The first part kind of looking at matter. So thinking about we're all chemists. In this space, we are all chemists. All right, I'm going to call you as such. What do chemists study? All right, and that's what we're going to explore. Chemists study matter. Anything that has volume or occupies volume or takes up space or has mass is matter. That's what we study. We look at, observations, behaviors of matter, and we relate that to what stuff is the matter made up of. So that's what we'll explore in the first part of the chapter. And in the second part, we will look at numbers. Essentially, we'll think, okay, how do chemists use numbers, measurements to measure what they study? That's the second part of the chapter. All right, so let's think about why we are here. Okay, so chemistry, I love chemistry. If you haven't noticed, I love chemistry because it helps us answer a lot of the just genuine questions I have about the world around me. All right, so chemistry is all around us, and it's really vital to a lot of different degrees and fields of study within the sciences. All right, so I really truly believe that everybody is a chemist, not just the people in this room, but my 5-year-old niece, she's a chemist. Even my older in-laws, they're chemists in some way when we think about chemistry and how it drives our lives. So the funny thing, chemistry, so you see where chemistry kind of lies on this chart. It's in the middle, right? So oftentimes scientists, they call chemistry the central science. Okay, so if you take Chemistry 1210, look at their textbook that they use, the name of the textbook is Chemistry, the Central Science, because it is vital to a lot of different STEM sciences out there. All right, so I kind of want to address like chemophobia, or the idea that chemicals, they're bad. All right. So I won't deny that I understand and recognize that kind of notion is out there. But remember, hopefully I can change the whole tide within chemicals and the connotation within chemicals. Everything is made up of chemicals. We are made up of chemicals. The periodic table, everything that makes up our bodies is listed on the periodic table. There's nothing inherently bad about chemicals. There are some bad ones out there, but to just kind of have that blanket statement that chemicals are bad is not entirely true. All right, so when we throw around the words like natural and organic, the FDA gives definitions to what those mean, and you'd be surprised what those words actually mean. So something can be natural and be a chemical. All right, everything that we touch, see, feel, those are chemicals. Everything that we interact with, it's not chemical free. There's no such thing as something that's chemical free. So water, so ubiquitous within our lives, is a chemical. Useful things within our lives, macronutrients, are made of elements that are chemicals off of the periodic table. So do recognize that. So why are you here? Again, chemistry surrounds us, makes up everything around us. And really my goal here within this course is to help you just look at the world through the lens of a chemist. Recognize, okay, chemicals aren't inherently bad. It's their composition and structure is what gives the properties that we see. Sometimes the properties that we observe and see are bad, but sometimes they're good, right? You know that there are chemicals out there that are inherently good, like, we drink milk because we need calcium within our bones. Calcium is an element off of the periodic table. So I'm very, passionate about that, to kind of, stomp on chemophobia out there. Chemicals aren't bad. They can be. So why we're here, to understand the world a little bit more as through the lens of a chemist, we'll see some cool demonstrations. Everything that we learn here is based upon fundamental principles that we'll learn about. It's not magic, all right? What we see here in the cool demonstrations, it's not magic. They all have explainable phenomena, and that's really what the sciences are. So it's not magic. Okay, and so just examples of, again, to bash chemophobia out there, the whole thing like, okay, this is natural because there's no chemicals in it. That statement is completely false. Those things do not go together. So like, for example, this very expensive toothpaste, Tom's toothpaste, I guess it has that connotation that it's natural, right? Maybe because it's expensive, maybe. But if we look at the ingredients list on Tom's toothpaste, all right, where it touts itself as a natural organic alternative to toothpaste, if we look at the actual ingredients, okay, and I drew out the chemical structures of some of those things, you can see natural does not mean chemical free. Okay, so natural typically means it comes from living sources, or like natural sources that come from our earth. But what you see here are chemicals and structures that are chemicals. All right, so really if you compare the ingredients list of this Tom's toothpaste and just like regular Colgate, you will see mainly the same exact ingredients. All right, so I just want you to kind of be a little bit more critical of the world around us. Or, an egg. I feel like there's nothing more natural than a chicken-laid egg, all right? But if we really look at the details of an egg and what constitutes an egg, the proteins, the different molecules within the yolk or the whites of the egg, if we really looked into the details of the amino acids that make up, this natural thing, an egg, we see really, really complex structures and chemicals within that egg. So hopefully at this point I have convinced you that everything is made of chemicals. Natural does not always mean good. Natural definitely does not mean chemical free. Everything is made of chemicals. Okay. So don't be scared of chemicals. So that's the big thing here. Okay. So last thing here. Oh, I'm not even using my notes. Where are we? Okay, map of chemistry. I like this picture. I think it just looks nice, okay? So the map of chemistry, what you see here are kind of two different realms. And this kind of gives us structure for, our place in this world and within this course. What you see here in green, that is like what we're studying during this course, the fundamental principles that drive chemistry. On the yellow side here, what you see are applications of chemistry that you could possibly use. So all chemists will learn the stuff in green, and that's what we will learn, those principles. And then we can apply those in a lot of different ways. Within here, so we can learn these concepts, and then you might be drawn to one or more of these different applications. For example, me personally, I am an inorganic chemist, meaning that I like to study metals. So like the middle left part of the periodic table. I don't really like living things. So I kind of went the opposite way. I want to study dead things, so inorganic, metals, things that are not composed of living things. So what we'll learn here when we dive deeper into the periodic table, a lot of the elements on the right side, so like carbon, nitrogen, oxygen, those are our non-metals, so that's what constitutes organic chemistry, and we'll talk a little bit about organic chemistry, but those are the elements that make up basically the majority of living things: carbon, oxygen, nitrogen. And that's, basically the foundations of organic chemistry. So I tried to stay the hell away from that, so I went to the other side of the periodic table. So that's just a little bit about me. Okay, so map of chemistry. I think you can go, there's places on campus you can print out posters, and you like pay by the square foot. So maybe I should print this because I think it's really cool. All right, so what is chemistry? So I already said it. It's the essential science. We look at the composition and structure and properties of matter. So matter, I think I define it on the next slide here, is anything that has mass or occupies space. All right, so the big thing here, let's just kind of define composition and structure. Its composition is what is your matter made out of, and how are those atoms attached to one another? So those two things kind of go hand in hand. What is it made out of, and how are the atoms or elements bonded together? Because that really, really matters. So those two things, composition and structure, directly relate to what we observe. All right, so what we observe, properties and reactivity, or sorry, yeah, properties. So what kind of characteristics does it have? Is it dense, or is it not so dense? Is it, a gas, or is it a solid at room temperature? So what we observe about a substance, again, relates to what it's actually made out of. And then lastly here, also reactions. How does that substance react or behave when you combine it with other things within there? All right, so matter and chemicals. So here's the definition for matter: anything that has mass and occupies space. So if you can put it in a jar, it is matter. So, I mean, there's very little things that I can think of that isn't matter. But yeah, anything that has mass or occupies space. In this class, how we will represent matter is typically through formulas, elements off of the periodic table. That is how we will represent matter as chemists. So here is my secret to chemistry, and I'll constantly bringing this up. And I want you to recognize this, moving forward in your life, is that the behaviors, the properties that we see with a piece of matter is directly related to its composition and structure. So basically, if we go back to this slide, what we observe, all right, what we observe in a piece of matter is directly related to what it's made out of and how those atoms are arranged. And we will constantly see this popping up over and over. It's both of those things that affect what we actually observe in terms of properties and behaviors. And that is the secret to chemistry, and what we really should be thinking about in terms of inspecting the properties of matter, especially in the laboratory. The different things that you see and observe in the lab is directly related to, the actual substances you're working with. So I will constantly be talking about the secret to chemistry. I'll ask you, do you remember what the secret to chemistry is? And then you will say that behaviors and properties are directly related to composition and structure. All right, so I'll constantly be talking about that. All right, so how do we classify matter? Typically, as chemists, when we want to measure things, observe things, we want to work with pure substances. Okay, so we don't want like impurities within there. We want to just study one thing to make sure the observations that we're making is just based upon one thing. So a way that we classify matter to just kind of figure out, to make sure what we're working with is pure or not, we can classify stuff as either pure substances or mixtures. Yes, okay. And we'll look at the details of both. There's two types of pure substances: elements and compounds. And there's a different way we identify both of them. But what makes pure substances like elements and compounds similar to one another is that they don't vary from sample to sample. So for example, gold is an element. If you had a chunk of gold and I had a chunk of gold, they would both look the exact same on a particulate level. If we looked at them, if we shrunk ourselves down and looked at them at the atomic level, they would look exactly the same, okay? All right, so the likelihood that I have a chunk of gold is not very high, but so elements, that's what makes elements a pure substance, that they don't vary from sample to sample, that they look exactly the same. Same thing with compounds. So water, H2O is an example of a compound, so this is more likely that you have a glass of water and I have a glass of water, H2O. So if we look at the particulate level, both of them, they look exactly the same, where we have essentially this repeating unit of an H2O molecule just making up the entire sample. So the big thing with pure substances is you can't separate them by physical means. And we'll talk about some physical methods, so like distillation, filtration, or chromatography. So if I go to my chunk of gold example, if I have a bar of gold and I cut it in half, Did I change the bar of gold? If I have a bar of gold and I cut it in half, what do you have? You have 2 bars of gold. You didn't actually change the thing. So that's what makes gold a pure substance. Okay? Or water. If I have a cup of water and I pour half of it out, now I have 2 glasses of water, right? But it's still water in both examples. So that's what makes a pure substance a pure substance. So how we differentiate that from a mixture. Mixtures typically are composed of multiple pure substances. So for example, salt water. Salt water, how do you make salt water? You take salt, you dissolve it in water, right? So salt water has 2 different components. So if I separated salt water, right, I took the water away from the salt, somehow through like distillation or whatever, or let the water evaporate, now I would have pure water and salt separately. But then I could undo that all and just mix it back together. So that's what makes a mixture different than a pure substance. So the big thing here that separates mixtures and pure substances is that you can separate mixtures by physical means. That when you separate them, you do change not so much the composition, but you can separate the different components of a mixture either using distillation, filtration, or chromatography. So within here, mixtures, the big thing is that there's typically more than one pure substance, so example, salt and water, but they're not chemically combined, meaning that we can separate them. So if we have salt water, you can boil off the water, leaving the salt behind, for example. So let's go into more details here. So again, here's just kind of a diagram to outline the differences here. We got pure substances, elements and compounds fall under those 2, and then we have mixtures. Of the 2 types of mixtures, we have 2 different kinds, homogeneous and heterogeneous. And I'll go into the details within there. So a lot of homogeneous mixtures like salt water, it's completely uniform all throughout when you dissolve the salt, so you have homogeneous mixtures. Heterogeneous, typically you have different phases present. We don't typically work with heterogeneous mixtures in this course. We mainly work with elements, compounds, and homogeneous mixtures. Okay, so once it's 2 o'clock, I forgot to set an alarm, but at 2 o'clock, I will do the demonstration just to kind of set the tone for the class. We'll end class with a boom, essentially, all right? So, okay, so we have our types of matter, pure substances, and mixtures. So let's talk about pure substances first, elements. All right, so elements, these are our elements off of the periodic table. All right, so like my example, my block of gold. Okay, I have a block of gold, I cut it in half, I just have 2 different blocks of gold, but it's still inherently gold. All right, so that's really what makes up a pure substance, that when you try to separate it, it still retains its identity. In that case, we're not changing it, because that would be an example of a chemical change if we actually change the identity of the substance. So what you see here, elements on the periodic table. The big things why these are elements is because you can't decompose them any further. So if we go back to our block of gold example, and we cut the bar of gold in half, then let's cut it in half again, and again, and again, and again, and again, until you get to a single unit, a single atom of gold. It's still gold. So it retains its identity. It doesn't decompose any further. But the thing is here, once we get into subatomic particles in the next chapter, if we do try to split a single gold atom, then it is no longer gold, and we split it into its subatomic particles. But that's very, very difficult to do, all right? So you can't decompose elements any further, any simpler than that. So right now there's about 118 known elements, all right? If you walk around and see different periodic tables, I like to see down here, right? So these periodic tables are out of date. Because they're missing like 114 or 115, 113. So we've actually discovered all of those elements. They typically only exist for a couple milliseconds. So they don't really have like really official names like you see some of the other names of the elements. They only exist for a fraction of a second, and we don't really use them in our everyday life. We use a lot of the lighter elements much more often. But we will get very used to using the periodic table, understanding the names. We don't have to memorize any of the numbers. right? That's not necessary for this class, but we will learn how to use those numbers within the periodic table. So you should know the symbols and names for at least the first 30 elements, and I have a study guide for you in a little bit. So just some clarification of some terminology. So I say the periodic table of elements. These are the elements. But sometimes I throw around the word element and atom. So an atom is the simplest unit of an element. All right, so like if I go back to my gold example and I keep splitting that bar of gold until I have a single gold atom. That is what an atom is, an atom of a single element such as gold. So it's the single simplest unit of an element, so just one single atom. That's how we describe an atom. So here, what is the definition I use? Building block, smallest building block of matter. You can't decompose it any simpler using chemical reactions, because if you split an atom, then you actually split it into subatomic particles, so like lower than atomic, so subatomic particles like electrons, protons, neutrons, etc. Okay, so types of, the other type of pure substance we talk about, we got elements off the periodic table, so those are just up here. Compounds are when we take some of those elements and combine them together. Right, that's a compound. When we take two different elements, combine them together by forming chemical bonds. The big thing here is you have to combine them through chemical means, is how we produce a compound. So for example, water, H2O, is a compound because it has hydrogen and oxygen within its formula. So how we oftentimes convey pure substances is through either symbols or chemical formula. So H2O is the chemical formula for water. So if hopefully you can see, okay, H2O, that's a compound, and so that makes it a pure substance because we can use a formula to represent it. So based upon the chemical formula H2O, note that we put a 2 subscript under after the H, so that means that there are 2 hydrogens and 1 oxygen for every H2O molecule within there. So what you see here, a clarification of some terminology. We talked about elements and how they have atoms, that's their smallest unit. Compounds, when we start combining elements, the smallest unit of a compound is a molecule. And a molecule really is just when you combine any 2 atoms held together. All right, so it's no longer an atom. When you start to chemically combine things together, you start to form molecules, but we're still thinking kind of about a single unit. We can pick up a single H2O molecule. You have a question?
All compounds are considered pure substances?
Correct, yes. So of these pure substances, there's 2 kinds. Elements and compounds, yes. Okay. So there we go. Do we have an example? I want to do examples. Yes, okay, so let's do some examples. Using the words that we just learned, okay? We got compounds and molecules, we just talked about those, and atoms and elements. So let's go through this list and identify them as either a compound, molecule, atom, or element. We might have a combination of stuff, just so we know. So CH4, what do we think that is? CH4. Is it a element? No, it's not. Because CH4 isn't on the periodic table. But C, carbon is, and hydrogen is. So when we combine elements, we form compounds, right? So this is a compound. All right? Okay, oftentimes I write compound like that. I just take out all the vowels. All right, so CH4 is a compound, but if we want to be like really nitpicky here, if we are talking about just one unit of CH4, we would specifically say that's a molecule of CH4. So this is a compound and it's a molecule. All right. Let's just quickly look back at the definition of molecule, it's 2 atoms that are held together by chemical bonds. So if we look, so it's at least 2 atoms. So if we look here, hey, there's a total of 5 atoms there, a carbon and 4 hydrogens. So when we combine all of them, we form a molecule because there's more than 1 atom present there, okay? So CH4 is a compound and a molecule. So this next substance, CH3COOH, this is acetic acid. Okay, this is what makes like vinegar smell bad. Okay, so acetic acid, what do we think it is? Element or compound? Compound. Molecule or atom? Molecule, very good. All right, so it's the same thing. Okay, all right, now a little bit trickier. Neon. Element. It's an element. Great, because it's on the periodic table. Element. All right, but is it an atom? Or I shouldn't have started it. Okay, so the question is here now, is it an atom or a molecule? It's an atom because it's just one single neon. See, this is where it gets a little bit tricky. So this is an element and it's an atom. That's neon. Okay, but what about here? Br2. Little bit trickier. You said it's an element? It is a molecule, yes, because there's two BRs there, right? There's a subscript 2, so we have two bromine atoms there. So it's a molecule, because any molecule just has to have at least two atoms chemically bonded to one another. It is a molecule. But what else is it? It's an element also. Br is on the periodic table, and that's the only substance present there. It's not like BRH or BRO. That would make it a compound. It's just Br. There just so happens to be two of them bonded to one another. So this is an element, and it's a molecule. All right, so the big difference here, if we compare the last two that we did, neon and bromine, they're both on the periodic table, but neon, there's just one atom there, right? It's just neon, Ne, no subscript. But Br, bromine, also on the periodic table, so it's an element, but there's two atoms within one molecule. So there's a number of elements that exist in our world as diatomic. So here, bromine Br2 means it's diatomic, meaning there's two atoms in one molecule. So like bromine, hydrogen, H2 gas, that is a diatomic molecule, but it's still an element. Chlorine gas, oxygen gas, neon gas, those are all like N2, O2, they're diatomic molecules, but they're still elements because there's only one element present. So that's a tricky thing. All right, H2O. Compound or element? Compound. Okay, cool. All right, and then now molecule or atom? Molecule. Okay, O2. Element. Molecule or atom? Molecule. Okay, how could we write oxygen as an element and an atom? Just an O, yes. If I just wrote O, then that would be an oxygen atom. So just the oxygen element, but just one single atom. So the difference here, so oxygen kind of looks like this when we draw like the Lewis structure. We'll get to this later, but we have two oxygen atoms that are bonded together while we have just a single oxygen atom floating around there. Okay, and that would be an element. So that would be an element and a, what did we just say? Atom. In that instance, but you will never just see an oxygen atom floating around in our world. Oxygen always exists as O2. So the oxygen that we're breathing right now, it's not just an oxygen atom, it's actually an oxygen molecule. Okay, all right, so I promised you, what we're talking about, the secret to chemistry, that properties that we see in the substances that we interact with in life are determined by composition and structure. So just to remind you, composition means the atoms that make up the thing, the matter, and then structure is how are those molecules or those atoms actually bonded to one another. So how atoms are actually bonded to one another really affects properties that we see. So what you see right here are three different molecules. They all have the same formula, C3H8O. They all have the same exact atoms present in their formula. But the difference is that their atoms are bonded differently to one another. So like a little comparison I make, it's like how what we see here is that structure is really important within this example, because it's the structure that is different in all of them. You see that, right, in the picture? All the atoms, the different colors, they're bonded differently. So what we see in terms of properties, we observe very, very different boiling points with these substances. They're all made of the same things, but they behave so differently because of the actual, how the atoms are attached to one another. So for example, like me personally, I have two brothers, right? So like me, like a girl, and then two guys. But the question is, so that's like our composition, one girl, two guys. But then the question is, do I have two younger brothers? Am I the middle child? Or am I the oldest child? Am I the baby? Because that would really change your like family dynamic, right? Based upon that, I might just tell you, yeah, I have 2 brothers, but you don't know structurally how's my family arranged. All right, so that's another example showing that structure is very important in the properties that you actually observe. So you want to guess what I am? I'm the baby. I'm the baby. Okay. All right. So yeah, let's just end with the secret. All right, and we'll talk about mixtures on Thursday. So let's end class with a boom. All right. So we talked about water, right? H2O. H2O. H2O is what? A compound, an atom, a molecule. What is it? It's a compound. Great. So we're just going to simply make water today. Whoops. We're going to make water today. So what you see here is a balloon filled up with hydrogen gas, so H2. H2 is what? Hydrogen. It's an element, H2, right? But it's also a molecule because there's 2 hydrogen atoms bonded together. But it is still an element. And then we also have in this balloon O2. O2, also an element, also a molecule because there's 2 oxygen atoms bonded together. All right, so we're just going to simply rearrange the atoms, these 2 elements, we're going to rearrange the atoms to make water, H2O. All right, so I do have to note here that this is very loud. So if there are any dogs in here, you might want to bring the dogs out. Okay, so it's very loud. So I'll show you. So it's loud, so you'll want to cover your ears, but don't cover them like this. Or like this. Cover them like this, so like cup your hands and just kind of go like this. And like listen behind you, okay? You'll want to cover your ears. It's loud, all right? So we're just gonna simply make water. Don't worry, you guys are not in the splash zone, all right? So I'm gonna do this, we're just gonna make water. Simple compound, okay? I have my trusty, got my trusty fire extinguisher right there. Okay, everyone has cupped ears, cupped ears. Cupped ears, okay, all right. So this will set the tone for the rest of the semester. Woo. Okay, all right, I'll see you on Thursday, guys.